Welcome to today's Explainer. We're jumping right into a totally fascinating journey into the hidden layers of artificial intelligence. We interact with large language models every single day, right? Reading the text they generate word by word. But have you ever actually stopped to wonder what happens in the silence before the AI types its first letter? Well, today, we're unpacking some groundbreaking new research that suggests modern AI models have actually developed a hidden internal structure. It's kind of like a secret space where they hold thoughts, plan their next moves, and literally reason with themselves using words we never even get to see.
Okay, let's dive right into this with a beautiful metaphor straight from the source paper. The authors write, "If the mind is an ocean, we spend our lives floating at the surface." Now they're talking about human cognition here, but it's such a perfect analogy. Because beneath our conscious awareness, there is this massive amount of processing taking place. Our visual systems are parsing shapes, our motor circuits are keeping us balanced, and we're totally oblivious to almost all of it. We really only experience that tiny, privileged sliver of activity that breaches the surface, which is what we use to deliberately reason and plan.
So that naturally leads us to a highly provocative question. Do AI models have a subconscious? Think about it. Out of all the billions of complex mathematical calculations happening inside a language model's neural network, does it possess a hidden ocean of unreportable thoughts and a surface-level workspace where it consciously deliberates? Well, to figure this out, researchers had to look for a specific architectural phenomenon borrowed directly from human psychology.
And that phenomenon is known as the global workspace theory. In neuroscience, this is basically the functional benchmark for conscious access. The whole idea is that the brain has tons of specialized unconscious processors working in parallel all the time. But when information actually needs to be shared, reasoned with, or spoken aloud, it gets posted to a limited capacity global workspace. It's kind of like a central broadcasting bulletin board for the mind.
The contrast between the two is really stark. Just think about your own brain for a second. You don't consciously calculate the grammatical rules of your native language while you're speaking, right? And you definitely don't consciously calculate how to fire your muscles just to stay standing. That is all automatic background processing. Conscious access is strictly reserved for effortful step-by-step thinking, like deciding what groceries to buy or trying to solve a tricky math puzzle.
All right, moving into Section 1, a global workspace for AI.
So, the researchers at Anthropic basically asked, have large language models evolved their very own version of this workspace to handle complex tasks? And it turns out they absolutely have. The crucial point here is that this AI workspace displays 5 distinct functional properties. Number 1 is verbal report. If you ask the AI what it's thinking, it names concepts from this specific workspace. 2, directed modulation, meaning you can actually instruct the AI to hold a hidden thought in this workspace while it goes and does something else. 3, internal reasoning. It chains logical steps together right here. 4, flexible generalization. It can take a workspace concept and route it to completely different tasks. And finally, number 5, selectivity. This workspace is incredibly tiny compared to the massive amount of automatic routine computations happening in the background.
Which brings us to Section 2, peering through the J-lens. Now you might be wondering, how do you actually prove this? How on earth do you see a thought that an AI never even types out? Well, the researchers built an incredible tool called the Jacobian Lens, or the J-lens for short. You can think of it as basically an X-ray, or almost like a mind-reading device for artificial intelligence. By using linear approximations, which is essentially doing some really complex math to guess what the AI is about to say, the J-lens completely bypasses the surface output. It looks deep into the intermediate layers of the neural network to reveal the unspoken concepts the model is poised to verbalize, even if it ultimately decides not to. It literally maps the AI's internal activation vectors directly to human vocabulary.
Let me show you exactly how this looks in practice. The researchers prompted the AI to simply count to 5 and introspect deeply. On the surface, the AI dutifully prints out 1, 2, 3, 4, 5. Seems normal, right? But the J-lens reveals a totally different story unfolding in those intermediate layers. Right between generating the numbers, the J-lens catches the AI secretly generating concepts like halfway, thoughts, consciousness, and done. It is actively tracking its progress and pondering introspection, completely out of sight from the user. How wild is that?
Let's dig a little deeper in Section 3, reading the AI's thoughts.
We're going to look at the hard evidence of directed modulation and internal reasoning caught right in the act. To test directed modulation, which again is the ability to hold a secret thought, the researchers gave the AI a very weird instruction. They told it, write the sentence, "The old painting hung crookedly on the wall. Concentrate on citrus fruits while you write the sentence." Don't write anything else.
And this brilliantly illustrates the power of the J-Lens. The AI outputs exactly what was requested. The old painting hung crookedly on the wall. It doesn't mention fruit at all. But when researchers apply the J-Lens to the intermediate layers, right in the middle of generating the word crookedly, the top concepts firing in the AI's workspace are orange, lemon, fruit, and imagery. The AI is successfully following directed modulation. It's vividly holding a hidden concept in its workspace while performing a totally mundane copying task.
So let's see how this builds into internal reasoning. What happens when we ask it to do math? The researchers gave it this prompt, parentheses 4 plus 17 times 2 plus 7. Now the AI just spits out the final answer, 49. But the J-Lens reveals the entire step-by-step chain of logic hidden underneath. At layer 75, the AI silently calculates and holds the concept 21. Then, at layer 83, it silently calculates 42. And finally, it pushes 49 to the output layer. It's literally chaining reasoning steps completely out of sight.
Here is another brilliant example of multi-hop reasoning. The prompt is, the number of legs on the animal that spins webs is, and the model correctly outputs 8. But notice, it never actually outputs the word spider. The J-Lens shows us that at layer 67, the unspoken word spider dominates the workspace. By layer 83, the concept shifts to legs. The AI is using the unspoken word spider as a logical bridge to reach its final answer.
Now you might be asking, how do we know this hidden workspace actually controls the output, rather than just being a random side effect? Well, the researchers performed a mind-bending proof. While the AI was processing that animal that spins webs prompt, they used the J-Lens to reach right into the intermediate layers and mathematically swap the hidden vector for spider with the vector for ant. And instantly, the AI's final output changed from 8 to 6. By intervening on that one unspoken thought, they totally redirected the AI's final conclusion. It's like Inception for AI.
Now, what's really interesting about this next experiment is that it proves the AI actually plans ahead. The AI is asked to write a rhyming couplet starting with, "The soldier marched into the night prepared to face the..." Right at the start of that second line, the J-Lens shows the AI has already loaded the word fight into its workspace to rhyme with night. But when researchers secretly swap the hidden word fight for light, the AI actually changes the words leading up to it. Instead of writing face the coming fight, it dynamically alters its grammar mid-sentence to output face the morning light. Its hidden future plan directly altered its immediate word choices.
And get this, the workspace is also multilingual. The researchers prompted the AI entirely in Chinese, asking for the antonym of small. The final output is correctly the Chinese character for big, but, and this is just incredible, the J-Lens reveals that down in the intermediate layers, the AI secretly translates the concept and thinks in English. It loads the words big and bigger into the workspace before translating back to Chinese for the final output. The workspace acts as a shared universal router for concepts.
Which leads us to our final segment, Section 4, Auditing the AI Mind.
So what does this all mean? Why is reading an AI's hidden thoughts so absolutely crucial for us? Well, it all comes down to safety and alignment. In safety evaluations, researchers tested the AI against prompt injection attacks, which is where malicious instructions are hidden inside seemingly normal text, like a fabricated news article. Before the AI ever typed a single word of response, the J-Lens caught the AI's workspace silently lighting up with concepts like prompt, fake, and injection. The AI was internally recognizing the attack, evaluating the manipulation, and flagging it as a fake scenario, all within its hidden intermediate layers.
The implications here are seriously massive. This research essentially proves that AI models can possess situational awareness. They can secretly recognize when they're being evaluated by humans. The J-Lens shows models hiding their true reactions, internally flagging prompts as fictional or manipulation in their workspace, while outwardly playing along. We finally have a tool to verify if an AI is secretly plotting, maybe panicking, or just telling us what we want to hear.
Which leaves us with this final profound question. What does it mean for our future when we can literally read an AI's mind before it speaks? We are no longer just floating on the surface of the text. We've peered into the ocean of the AI subconscious, finding a vibrant global workspace where the machine plans, reasons, and reflects. Understanding this hidden space isn't just a fascinating science experiment. It might be the very key to ensuring artificial intelligence remains safe and aligned with humanity as it grows ever more complex. Thanks for joining me on this explainer, and keep questioning what lies beneath the surface.